lights are please. Perfect. Okay. Hello, everybody. Yes, I can be trained both years. And so actually, maybe next year I will try to find a way to have like all of you some guide on how to get here by train from the rest of Europe. So maybe we can try flying less. Okay, so, well, a deep dive into source maps. Many of us probably use source maps. Many of us hopefully use them without even knowing, because like when they work, they shouldn't appear. Like you shouldn't really notice them. So, well, I've already been introduced. Thanks, Joanna. So what are source maps? Well, and why do we need them? Regardless of what JavaScript 101 introduction say, JavaScript is in practice a compiled programming language. And I'm not talking about like V8 or SpiderMonkey internal will transform JavaScript to some like native code. No, we are the ones compiling JavaScript. We usually author like maybe some JavaScript, some TypeScript. We have some files. We might transpile them to remove types or to change the syntax. We might bundle them, like maybe with Webpack or something else. Then probably we're also minifying it to like make sure that our code in production is not too big. So this means that the code that you run is like not at all the code that you write. And like you try looking at it, it's just a completely different file. And like this is okay. It's still like all these tools that transform your code to make sure that it will behave the same. But like, what do you do when something goes wrong? Like, how do you debug it? And like, let's like take a look at a simple example to understand what I mean. Like, I have this code. The code is not really important. It's just like there is a bug somewhere here. And this is the code I'm writing. Then it goes through my building pipeline. I will run it in browser. And I get this error. State is undefined. OK, well, let's figure out why. Let's fix this error. So first, I look at this stack trace, where it tells me like the code path that caused the error to be thrown. And I see this happening at function n. So I go in my editor, I look at my code, I look for function n, and it just doesn't exist. So, well, likely the stack trace gives us also a second hint. It tells you this is happening in main.js, line 5, column 49. So I go in my editor, I look at line 5, column 49, and like, how is it possible that this nothing is causing an error in my code? And like, the reason this stack trace is wrong, it's because we're actually running some different code. We're running, let's pretend that this code is minified. I just like manually moved it around a little bit. We're actually running this code that's the output of our complete build pipeline. And if you go look here, line 5, column 49 actually exists. And like we're trying to read something from state here, and like for some reason it's undefined. And like in this specific case, I didn't really modify the code too much, so it's actually quite easy to tell what is going on. So it's quite easy to go in my original code and like figure out what this line 5, column 49 actually is. But like in general, like these transforms are much more complex, and it's much more difficult to mentally tell where the code we're running originally came from. So source maps are the solution to this problem. Source maps let dev tools look at the code that's running, and for every like important piece of your code, compute what the original code was and pretend that they're actually running the original code, even if it's not the code that it's like actually running. So with a source map, our error would now tell us, look, this is happening in line 11, column 31. So we go look in our editor, we pick line 11, column 31, and we immediately find the error. And like again, this is not the code we're actually running, but the dev tool is being helpful by telling us, look, I know that this is not the code you're running, but go check in that place. And like it's not super helpful in some cases. For example, we can see that the stack trace still says function n. Function n still doesn't exist. But like this is a screenshot from Firefox. Other types of dev tools will actually also tell, look, the original function was can read names. Node.js, for example, does that. And this is not just for JavaScript, even if JavaScript is the most common reason for using source maps. Like yesterday, we saw some mentions of Sass and less. You can use source maps when compiling them to CSS. So you go into DevTools, and you see This element has display block because it has been set in your less file in this position, and then you will check, and it's actually like inside maybe some loop or with some syntax that the browser would not understand. But thanks to source maps, the browser can tell you where in your original code the property was set. And we can also use them for WebAssembly when running native languages in the browser, like Rust, C, or many other. Like, who writes Rust code here? Okay, cool. I do not. But like, I have a little example here. Let me see if I can get it. Yeah, so I don't write Rust, so I prefer C. Well, I know how C works. So like, I have this. I have like this little C library that just computes like the Fibonacci numbers. And like this obviously by itself doesn't run in a browser. I need to compile it. I'm using mscripten, which is like a tool to transform well, C and other languages into WebAssembly so they can run in a browser. So it generates some WebAssembly code. Now again, the code here. Like this is like the compiled output, and then I have like some file that is importing this function and just calling this C function. And like if I go look in my browser, open the DevTools. No, oh, I forgot how to open the DevTools. Okay, like if I go look at my browser, oh wait, I have source maps disabled, and with source maps disabled, like all I can see is my WebAssembly code, and like this is not very helpful. If there is a bug, I can try debugging this, but like this is not the code I've wrote, and like I don't really know how. Even if I don't really know how to debug this code. So what I can do is to enable source maps, JavaScript source maps. I probably have to reload. Probably have to reload, and now if I go look here, I find my original lib folder that contains my original C file. And like the browser doesn't understand what's going on here, but it's still showing me this file because I have some map that's mapping the WebAssembly code to my original source. And like I can even debug this code. Like I can place a breakpoint here. Let me reload the page. And like the browser will like step the debugger in my C code. And like again, the browser is not really understanding the C code, but I can like move across the line and see how things are evaluated. Source maps are not perfect. Like for example, mscripten doesn't preserve variable names, so I cannot really see in my like scope tab in the debugger that I have a variable temp, a variable a, and a variable b. But still, being able to debug my C code in browser is like incredibly helpful. And like this is an example, but what's common is maybe running TypeScript or you're running some code that's being minified. So, okay, so how does this work? Like, how is this possible? Or, well, what does a source map look like? And so now we're actually gonna go a little bit deep. A source map is just a JSON file that has some properties. Some of these properties are like, don't really matter for the mapping. For example, we have version field that if you ever look at a source map, version is always 3. It's just like there are no other versions. It has a file name that's just the name of the file it's been mapping. And then there are some interesting properties. For example, we have names. That was the list of original function names, variable names, query number files. We have some sources. Sources was the file names of the original files. And before actually looking exactly what this sources does, I want to show you some code that this source map is trying to map. So I have this main.ts file. It's just a JavaScript file, contains an interface, a class, and then creates an instance of that class. I need to transpile my TypeScript code. I'm also using Babel because, let's say, I want my code to run in Internet Explorer. That's not the code I'm running. This is the code I'm actually running. So my class has been transformed into a function. All the types have been removed. And like you can notice here that there is this source map URL comment. This is the comment that, this is the way we signal to browsers, look, go check what my original code actually was. So the browser will download this like main.js.map file in this case, which is like this like magic transformation between the original source and the new code. So what this source array does is basically telling us this main.js file was actually a source/main.ts. And like in this case, I only have one source because I'm just transpiling a file. But like, what if I'm bundling? I might have multiple sources. Like a file can be made out of multiple original pieces. Similarly, we have source contents that tells the browser the contents of that source/main.ts files were this. So the browser knows, okay, we're running this JavaScript code, but actually it looks like this. And again, we might have multiple files bundled together. And this is enough to actually see our code in the DevTools. Like in this case, we're seeing the TypeScript code. But this is like not enough yet, because the browser doesn't really understand this code. So if, for example, I want to place a breakpoint somewhere, how does the browser know where that breakpoint actually is? Or like if there is an error with some stack trace, how does the browser know where that stack trace actually is in the original code if it cannot understand the meaning of the original code? Okay. And like this is where mappings helps us. Mapping is like where the actual magic happens. And well, let's just try reading together what they're telling to the browser. They're telling Aka, Sama, Gibawa, Kaif. And clear, right? So what does this actually mean? First of all, you might see that we have these random words like divided by commas, by semicolons. What's happening here is that these are basically sentences that are telling the browser line by line what's happening. And the sentences are like split apart by semicolons. So we can actually start breaking our mappings apart and saying, okay, so this first line of our code, function class underscore amazing path, is mapped by this Aka, Sama, Gbawa, Kaif. So let's just focus on that. What does that mean? Again, now we have this first sentence. Let's split it into multiple pieces. And let's look at every single word one by one. So Aka, what does Aka mean? Well, we need to decode this. Source maps follow that format with like seemingly random letters to be as small as possible because they need to convey a lot of information. They need to basically map every single important point in your file to the original equivalent important point. So this format was chosen to just be as compressed as possible because you really want to load too much in your DevTools, otherwise like they need a lot of memory to parse everything, you're gonna slow everything down. So to decode this, first thing we need to convert it from base 64 to binary. And like in this specific case, A means 0 and K means 0, 0, 1, 0, 1, 0. I'm not just coming up with random numbers. There is actually a standard base 64 encoding in RFC 4648. This is the same type of encoding that's being used when you like try to base 64 encode a binary file, for example. It uses uppercase letters, lowercase letters, numbers, and then plus and slash. So we converted our base 64 into binary. And be careful here because these 4 sets of bits are not actually bytes. Well, we could still call them bytes, but they're not 8 bits long. They're just 6 bits each. And usually when you use base 64, you still then rearrange them to have pieces of 8 bits. But for source maps, we need to keep these bytes 6 bits long. So once we have these bits, what do they actually mean? Well, we start by just ignoring the first and last bits from every byte. So our source map here is actually encoding this 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, and so on. We check, we convert this to base 10, And this is actually where the information starts making sense. 0050, well, still doesn't help us much. Like, these numbers are actually telling us that column 0 in our original file is mapping to our source 0. In this case, we just have one source, so it's obvious. But like, as we saw, we might have multiple sources for a final bundle file, and so we need to know where everything is coming from. Source 0, line 5, column 0. And like here still there is something a little bit off, because if you look at line 5 here, there is not actually any code in line 5. So what is this actually mapping to? Source maps columns are 0-based, again, to save some space. Otherwise, you're wasting line 0. So this is actually telling us that this function was originally this class. So if, for example, we were to open our DevTools, see our TypeScript code, place a breakpoint in line 6, where the class starts, it would know that the breakpoint needs to stop at the function keyword. And we can go on. So we have Sama, and I know that it's difficult to follow exactly how these bits are moving. That's why we're actually gonna do it like a couple times just to get used to it. So step 1, convert base64 to binary, again following the table. And like, if you want to try yourself, just Google for base64 alphabet and you will find the table as the first result. We ignore the first and last bits. We convert to base 10, so Sama means 90060. We go put these numbers in our, I guess, decoding slides, with just one caveat that, again, to keep source maps as small as possible, these numbers are not actually 90060 anymore. They're relative to the previous mapping. So we're actually adding 9, adding 0, adding 0, adding 6, and we get 90560. So this is column 9, source 0, line 5, column 6. Well, column 9 of the original of the file that we're running maps to the original source number 0, and line 5, column 6. And we have this extra 0 at the end that we didn't have before. This is to map names. So if we go back to our source map and we look at this line, we see that we have a list of just words. This is telling 0 is the name number 0, which was Amazing Pet in our array. And this is so that tools that support showing us the proper stack traces, like Node.js, will tell us, like for example, if there is an error in our function class Amazing Pet, they will tell us that the error was originally inside the Amazing Pet class using the original name. And we can just go on, so gibawa, convert to base64. This time we're not actually ignoring bytes starting with 1. I was lying. I don't know if you noticed, but all my bytes were starting with 0 before. So we could just ignore the 0. Whenever there is a byte that starts with 1, we need to merge it with the next byte. So we ignore the first and last bits. We take these first zeros, but then the one bit that we ignored was a 1, so we have to go grab the second byte. The second byte starts with 0, so we're done. If it were to start with 1, we would go get more and more byte. This is called VLQ, or variable length quantities. And this is needed so that we can encode potentially huge numbers, because like our files might have hundreds of lines. And like if we just have 4 or 6 bits, the biggest number we can encode is like either 16 or 64, so that's not enough. So source maps do this by basically merging letters together. And then again, those are all zeros, we can just ignore them, we convert to base 10, we add to the previous mapping, and we get that column 25 in the file that we're running is actually line 0, source 0, line 5, column 0, and again, this is mapping up a name, so we still store the name in case debuggers will need it. And we continue. So Kaif, convert base64 to binary. And again, I didn't tell you all the truth before when I told you to just ignore the first and last bits and check maybe if the first bit is 0, because now we have a byte ending with 1. Whenever a byte ends with 1, we have a negative number. And like, it doesn't really make sense to have negative columns or negative line numbers, but like, let's then ignore everything, convert to base 10. Like if you remember that we're actually relative to the previous mapping, negative number is useful to like, well, go back. So before we were at column 16, and now we're actually mapping to column 14. I'm gonna stop. Going through all bits is like not the easiest thing to do. Like imagine DevTools have to do this process for every single mapping in our file. And there are actually some problems with source maps. For example, you cannot just say, let's check what this line 100 is, because the browser will have to all the time start from scratch, because everything is like relative, so they've always start from first mapping. But like the goal here is again to try to make them as small as possible. And well, you can try it yourself. I don't think anybody will, to be honest. It's not the most easy task to do, and the browser will do it for you. So why am I talking about all of this? Well, as Jana mentioned before, I work in TC39. That is the body where we write JavaScript standard, and we try, like, ideally our goal is to make the life of developers as easy as possible. And recently, a group made of like browser authors and authors of different JavaScript tools gathered together to actually work on a source map standard. Why do we need a standard if you already have source maps? Well, so far, source maps have had a, let's say, description of how they work. There was this Google Doc on the Google account on some person working at Google saying, look, we have this compiler, Google Closure compiler, if you've ever heard of it, that like transpiles and minifies code, and we need a way for this to be debuggable. So we invented this format of doing so, we implemented it in Chrome, and this is how we did it. And then like this was useful, so other browsers started implementing it, tools that transform code like bundlers or minifiers started trying to look at this document to understand what they had to do and try to match what it said. Like this had a problem, that is that this was like not as clear as a proper specification. This was like a description of what was going on. And so it was difficult to make sure that everybody was behaving the same. So maybe your source map works in Firefox. You can debug your code in Firefox. Then you try and open it in Chrome, and there is something a little bit off. And also, source maps are not perfect yet. Ideally, you should just debug your original code in your browser without noticing they're there. But like very often, they're just not enough. And like you see that there is some layer of abstraction that's not working perfectly in the middle. So we need to evolve them, and like how it's like very difficult to collaborate if there is no shared understanding of what source maps should be. And so like we started this effort a couple of months ago. And again, like why do we need a standard? To make sure that everybody actually agrees on what source maps are. And like an example of some case in which not everybody agrees is how, even before starting reading the source maps, how do you tell that a file has a specific source map? There is like this source mapping URL comment that you place at the end of your file, and it points to the map, and then the map will contain information. And like if you go read at what is now the spec that was original Google Doc, this comment should be at the end of your file. But like what happens if, for example, you have other comments after it? Or like what happens if some code after this comment? Or if you have something that might either be code or might be a comment. And like this looks like edge cases. But like people will eventually run into edge cases. So it's very important to make sure that everybody agrees on how these edge cases should be handled. And like, for example, until a couple months ago, in this case, Node would either load or not the source map, depending on whether your code was running as ESM or CommonJS. Or like some browsers were loading it, other browsers were not. Because again, we have an edge case, and that document was like not clear enough, and so everybody just did whatever they wanted to do. So yeah, so like we are hopefully gonna have tools that are working all the same, that are letting you forget that there is some abstraction going on because the abstraction just works. And like once we're done with that, once everybody agrees on what source maps are, we can actually start evolving them. We can start adding features to make the debugging experience easier. Like something that very recently landed, ignore list, is like another source map property that lets you ignore some files in stack trace and debuggers. So for example, you might be loading some polyfill, or maybe there is some bundler internal helpers that like Webpack is emitting that you don't really care about when you're trying to debug your code. And so tools can say, okay, I included these files, but actually hide them for the developer. They're just an implementation detail. And when they're debugging their code, they should debug in these main TS and utils TS files. And like tools still allow you to override this ignoring list, but like what's important is that the debugging experience lets you focus first on what's most important, and then you can like go in some advanced area to focus on the underlying code that you didn't actually author. Or something else is like a new proposal for source maps called scopes. So source maps allow mapping, as we saw, locations. So we can say line 0, column 5 was actually line 32, column 6 in Nicode, and let you map variable names. So you can see that the function class underscore amazing pet was actually called just amazing pet in the original code. But like, is this enough? Well, no, it's not. Otherwise, I wouldn't be asking if it is enough. Like, for example, something very common that minifiers do to try making your code as small as possible is to perform some inlining. So we have this code on the left. We have two functions, and the function on the bottom is calling the function at the top. So what minifiers would very often do is to just, if this other function is only called there, they just take its body and inline it inside run. Or, for example, if we have some constants variables that are so short that the value of the variable is just like smaller than declaring the constant itself, they might inline the value where it is used. And all these transforms are eventually to make your code either faster or smaller, or to, in general, make sure that the final user experience is better. But this hurts the debugging experience. And like source maps here cannot really help, because like even if you know that this if e greater than 2, so line 3 was actually, well, also line 3 in the original code, what if that console.log call for some reason throws an error? You look at the stack trace and you see that the error is being thrown from the run function. So you go in your original code, you check the run function, and like the console.log is not actually there. You would actually have to go look in the logifbig function, except that the function doesn't exist anymore at all, so it cannot be present in the stack trace. And so like with scopes, we're trying to solve these problems where we can say, look, this was originally a different function, or originally in this function there was this variable that doesn't exist anymore. Yeah. So what's next? We are currently trying to find all the pain points related to debugging code caused by the code being run not being the same code that the developers wrote. We're working with tool authors, with browser developers, and like we would be very happy to receive feedback from just like, JavaScript developers that are using some tools to transform their code and then they have to debug it. And like the final goal here is to make sure that these abstractions work so well that you will not notice it being there, and that like everything will just work, and you will be able to debug your TypeScript code directly in the browser, your C code directly in the browser, without having to worry about the internal build steps that are actually happening. And this is it. I hope you learned something today. If you want to look for my slides, I've linked them on my website, nicar.dev. If you want to like try going by yourself through how the coding works, it's a fun and rewarding experience once you learn like, how to actually do it. Thank you for listening.